Hello, in this lecture we'll find out the radius of the circle. In the drawing we have a circle. Inside this circle we have chord AB that is equal to square root of 2 units, chord DB equals to 2 units, and this angle DEB equals to 45 degrees in its size, and our mission is to find out the radius of this circle. Okay, so we use two rules in order to solve this question. The first rule is that the central angle is twice as big as the peripheral angle resting on the same chord. Repeat again. The central angle is twice as big as the peripheral angle resting on the same chord. Here we have peripheral angle ACB that is equal to alpha, and it rests on chord AB. And this angle AOB, is a central angle that rests on the same chord AB. Therefore, it must be twice as big as the peripheral angle. The peripheral angle equals to alpha, therefore the central angle must be equal to 2 alpha. Okay? Again, the peripheral angle and the central angle is twice as big as the peripheral angle resting on the same chord. Okay, those two angles are resting on the same chord. This is the peripheral angle, this is the central angle. Therefore, if the peripheral angle equals to alpha, the central angle must be equal to 2 alpha. This is the first rule. And we have the second rule also. That is the law of cosines. The law of cosines is true in any triangle. So this triangle ABC, could be any triangle. The length of side AB is A units, side AC equals to B units in its length, side BC equals to C units in its length, and this angle BAC equals to theta. Then, according to the law of cosines, the following equation is true: that C squared equals to A squared plus B squared minus 2 times A times B times cosine alpha. Okay, again, C squared equals to A squared plus B squared minus 2 times A times B times cosine alpha. So, from this equation, it is very easy to arrive to this equation that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Okay? So we define the center of this circle, this point, as O. We join points O and P, let's line points O and T, points O and A, and points O and B. Okay. So all those four line segments, line segment OB, line segment OD, line segment OA, and line segment OB, exiting from point O, and then they start from point O and ends at the points on the circle itself. That is to say, on points O, B, D, A, and B. So this is exactly the definition of a radius. We'll define the radius of this circle as R. Therefore, OB equals to R, OD equals to R, OA equals to R, and finally OB equals also to R. Okay. So if we focus on the straight line AB at point E, according to rule number 1, then the sum of the angles on one side of the straight line is equal to 180 units. So at the upper side of the straight line AB at point E, the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of AB at point E? We have this angle equals to 45 degrees plus the missing angle. In total, the mark must be equal to 180 degrees. So the missing angle must be equal to 135 degrees. Okay, in order to complete the sum of the angles at the upper side of AB at point E to 180 degrees, the missing angle must be equal to 135 degrees. 135 degrees plus 45 degrees is 180 degrees. Okay, so here we will define this angle ADB as y over 2. Peripheral angle ADB, this angle equals to y over 2 degrees in its size, and peripheral angle ADB rests on chord AB. Okay, again, peripheral angle ADB rests on chord AB. Therefore, the central angle that rests on the same chord AB, must be equal twice of y over 2. So here we have peripheral central angle A or B that also rests on chord AB, and therefore it must be equal to y over 2 times 2 is y. Okay. Likewise, we have peripheral angle BAD that rests on chord DB. We define this peripheral angle as x over 2. Again, this peripheral angle BAD rests on chord DB. Therefore, the central angle that rests on the same chord DB must be equal to x over 2 times 2, that is x. So, the central angle DOB rests on the same chord DB, therefore it must be equal to x. Okay, in the next step, we'll focus on the green triangle. Focus on the green triangle AED. This green triangle AED. In this triangle, as it is true in any triangle, the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Okay. So here triangle AED. So which angles we have inside triangle AED? we have this angle that is x over 2 plus this angle that is y over 2 plus this angle that is equal to 135 degrees. In total, they must be equal to 180 degrees. Okay. Repeat again. In the green triangle AED, the sum of the angles must be equal to 180 degrees, that is to say x over 2 plus y over 2 plus 135 degrees equals to 180 degrees. We subtract 135 degrees from this equation, and we get that (180 minus 135 degrees is 45 degrees, and it is equal to x over 2 plus y over 2. Here we multiply this equation by 2, and you get that x over 2 times 2 is x, y over 2 times 2 is y. It is equal to 45 times 2 is 90 degrees. So we found out that x plus y equals to 90 degrees. We subtract x from this equation, and finally we get that y equals to 90 degrees minus x. Okay. In the next step, we will implement the law of cosines in the pink triangle ODB. The pink triangle ODB, according to the law of cosines, cosine x equals to r squared plus r squared minus 2 squared. 2 squared is 4, so it is minus 4 over 2 times r times r. Repeat again. In the pink triangle ODB, according to the law of cosines, cosine x equals to r squared plus r squared minus 4 over 2 times r times r. R squared plus r squared is 2r squared. Minus 4 over 2 times r is 2r squared. Okay. So according to equation number 1, cosine x equals to, we split this expression into 2 parts. The first part will be 2r squared over 2r squared. The second part will be minus 4 over 2r squared. So here we found out that cosine x equals to 2r squared over 2r squared is 1. Here we have minus 4 over 2 is minus 2, so in the numerator we have minus 2 over, in the denominator we have r squared. So actually, according to equation number 1, we found out that cosine x equals to 1 minus 2 r squared. In the next step, we will implement the Pythagoras, the law of cosines on the yellow triangle, triangle AOB. In the yellow triangle, triangle AOB, according to the law of cosines, we get that cosine y equals to r squared plus r squared minus square root of 2 squared. Square root of 2 squared is 2, so it is minus 2 over 2 times r. Okay, so actually this equation number 2 is the implementation of the law of cosines on the yellow triangle, triangle AOB. Okay, so cosine y equals to r squared plus r squared is 2r squared minus 2 over 2 times r is 2r squared. So cosine y equals to, we will split this expression into 2 parts. The first part will be 2r squared over 2r squared, and the second part will be minus 2 over 2r squared. So we found out that according to equation number 2, cosine y equals to 2r squared over 2r squared is 1 minus 2 over 2 is minus 1, and in the denominator we have r squared. So according to equation number 2, cosine y equals to 1 minus 1 over r squared. And according to equation number 1, cosine x equals to 1 minus 2r squared. In the next step, we substitute 1 over r squared by t, that is to say 1 over r squared equals to t according to our definition, and we substitute 1 over r squared in both equations number 1 and number 2 by t. And we get that according to equation number 1, we have here cosine x equals to 1, and we have minus 2 times 1 over r squared. So it is minus 2 and 1 over r squared is t, so it is minus 2t. So according to equation number 1, cosine x equals to 1 minus 2t. Actually, we have in equation number 2 cosine y and we have already found out that y equals to 90 degrees minus x. So we substitute y in this equation number 2 by 90 degrees minus x. So cosine y equals to cosine y is 90 degrees minus x. So we substitute y by 90 degrees minus x. So here cosine y equals to cosine 90 degrees minus x, because y equals to 90 degrees minus x. And we have the trigonometric identity that actually cosine 90 degrees minus x equals to sinus x. So in conclusion, we found out that according to equation number 2, cosine y equals to sinus x. So we substitute cosine y in equation number 2 by sinus x, and we get that according to equation number 2, we have cosine y, so cosine y is sinus x, is equal to 1 minus 1 over r squared. According to equation number 2, sinus x equals to 1 minus 1 over r squared. And according to our definition, 1 over r squared equals to t, so we substitute 1 over r squared by t, and we get that sinus x equals to 1 minus 1 over r t, 1 over r squared is t, so we substitute 1 over r squared by t, so it is minus t. In conclusion, we found out that according to equation number 2, sinus x equals to 1 minus t, while according to equation number 1, we have already found out that cosine x equals to 1 minus 2t. Again, according to equation number 1, according to equation number 2, sinus x equals to 1 minus t. Okay, so we have here expressions for cosine x and for sinus x. In the next step, we will use the trigonometric identity that states that sinus square x plus cosine square x equals to 1. sinus x equals to 1 minus 2t, therefore sinus square x will be equal to 1 minus 2t square plus cosine square x. Cosine x equals to 1 minus 2, cosine x equals to 1 minus 2t. Here sinus x and cosine x equals to 1 minus 2t, and here sinus x equals to 1 minus t. So here sinus x equals to 1 minus t, therefore sinus square x equals to 1 minus t square. And there cosine x equals to 1 minus 2t, therefore cosine square x equals to 1 minus 2t square, and all equals to 1. Okay. In the next step, we'll open the brackets on this side of the equation, and we get that one minus t square equals to 1 squared, that is 1, plus t square minus 2t. We'll open the brackets of this expression also. 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared, that is 4t squared, minus 2 times 2t is minus 4t, equals to 1. So here we have 1 on both sides of the equation, so 1 will get cancelled, and we're left only with 1 here. So here we have t squared plus 4t squared is 5t squared, minus t minus 4t is minus 6t, and we have plus 1, all equals to 0. In the next step, we substitute minus 6t by minus 5t minus 1t, and we'll get that 5t squared minus 6t is minus 5t minus 1t, plus 1 equals to 0. Okay. So here we'll take a common factor of 5t from those two expressions. So what is left from 5t squared after we took from it 5t as a common factor? What is left is actually t, and what is left from minus 5t after we took from it 5t as a common factor, what is left is actually minus 1, and we'll take out a common factor of minus 1 from those two expressions. So what is left from minus t after we took from it minus 1 as a common factor? What is left, it is actually t, and what is left from plus 1 after we took from it minus 1 as a common factor, what is left, it is actually minus 1. Why? Because minus times minus is plus, equals to 0. The next step, we'll take out t minus 1 as a common factor from those two expressions. So what is left from 5t times t minus 1 after we took from it t minus 1 is second factor, what is left is actually 5t, and what is left from minus t minus 1 after we took from it t minus 1 is second factor, what is left is actually minus 1 equals to 0. So here we have two solutions that are possible for t, from the value of t. Either t minus 1 equals to 0, and the second solution is that 5t minus 1 equals to 0. We focus on the first solution. If t minus 1 equals to 0, it means that t equals to 1, and according to our definition, t equals to 1 over r squared. So we substitute t in this equation by 1 over r squared, and we get that t is 1 over r squared equals to 1. We multiply this equation by r squared, and we get that r squared equals to 1. We take a root out of this equation, and we get that r equals to plus minus of square root of 1. Okay, the negative square root of 1 is minus 1. But because of the fact that r is a length, and a length must be a positive number, r cannot be equal to minus 1, so we'll cancel the solution, and we're left with the only solution that r equals to the positive square root of 1, that is 1. So in conclusion, we found out that r equals to 1. Okay. The next step, we will focus on the second solution. 5t minus 1 equals to 0. We'll add 1 to this equation, and we'll get that 5t equals to 1. We'll divide this equation by 5, and we get that t equals to 1/5. T equals to 1/5. According to our definition, t equals to 1 over r squared. So we substitute t by 1 over r squared, and we get t is 1 over r squared equals to 1/5. Okay. So here we will cross multiply this equation, and we get that r squared equals to 5. We take a root out of this equation, and we get that r equals to the root of 5, or plus minus the root of 5. So the negative r equals to the negative square root of 5. But again, because of the fact that r is a length and the length must be a positive number, r cannot be equal to the negative square root of 5, so we cancel that solution, and we're left with the only solution that are possible, that r equals to the positive square root of 5. So in conclusion, we have two solutions for this equation for t. Either r equals to the square root of 5, or r equals to 1. In the next step, we'll focus on the original drawing, and here we have chord dB that is equal to 2 units. It is very easy to see that chord dB doesn't pass through the center of the circle. That is to say, chord dB doesn't pass through point O, that is the center of the circle. Therefore, chord dB is not the diameter of the circle. Why? Because any diameter of a circle must pass through the center of the circle. Okay, chord dB is not the diameter of the circle. In addition, you know that the diameter of any circle is the longest chord on the circle. Therefore, the diameter 2r is the longest chord of this circle. Therefore, it must be greater than dB that is not the diameter of the circle. In conclusion, we found out that the diameter 2r must be greater than dB. Okay, repeat again. The diameter 2r must be greater than dB. Again, because dB is not the diameter, and the diameter of any circle is the greatest chord in the circle. Therefore, the diameter of 2r is greater than dB, that is not the diameter of the circle. And it is given us the question that dB equals to 2 units. So we substitute dB by 2 in this inequality, and we get that 2r is greater than 2. We divide this inequality by 2, and we get that r is greater than 1. R is greater than 1. If r is greater than 1, it means that the solution that r equals to 1 is not correct, because r must be greater than 1. So we cancel the solution, and we left the only solution that are possible for r. The only solution that are possible for r is that r equals to the square root of 5. Or in terms of numbers, it is equal to 2.236 units. And that is the answer to the question. Repeat again. The radius of this circle r equals to either square root of 5 units, or in terms of numbers, it is equal to 2.236 units. Okay, so in the next step, I'll summarize the lecture. In this lecture, we found out the radius of this circle. Okay, you know that chord dB equals to 2 units, chord AB equals to square root of 2 units inside, and this angle VED equals to 45 degrees. Again, our mission is to find out the radius of this circle. We use 2 rules in order to find out the radius of the circle. The first rule is that the central angle is twice as big as the peripheral angle resting on the same chord. Repeat again. The central angle is twice as big as the peripheral angle resting on the same chord. So here we have chord ACB that rests, we have angle ACB that rests on chord AB, and we have angle AOB that rests on the same chord AB. And according to this rule, the central angle is twice as big as the peripheral angle that rests on the same chord. Those two angles are resting on the same chord AB. So if the peripheral angle ACB equals to alpha, it means that the central angle must be equal to 2 alpha according to this rule. Okay? This is the first rule. The second rule is the law of cosines in any triangle. Triangle ABC could be any triangle. If side AB equals to A units, side AC equals to B units in length, and side BC equals to C units, and this angle BAC equals to theta, then according to the law of cosines, in this triangle ABC that could be any triangle, C squared equals to A squared plus B squared minus 2 times A times B cosine theta. Okay, so from this equation, it is very easy to arrive to this equation, that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Okay, in the next step, we define the center of this circle as O. Then we join points O and B together with a straight line. We join points O and A. We join points O and D, and we join points O and B by a straight line. Those 4 line segments they all start from point O and ends at points on the circle. Ends at point B, A, D, and ends at points B, A, D, and this point. And this is exactly the definition of a radius. Okay, any line segment that starts from the center of the circle and ends at any point on the circle must be the radius. So those 4 line segments are the radii of this circle. We define the radius of this circle as R. So here OB equals to R, OD equals to R, OA equals to R, and here this line segment OB also equals to R. Okay, then we focused on the straight line AB at point E. We have this angle on the upper side of the straight line AB at point E. We have angle that is equal to 45 degrees. We have the missing angle. The sum of those 2 angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line equals to 180 degrees. So the sum of the angles on the upper side of this straight line must be equal to 180 degrees. So if this angle equals to 45 degrees, the missing angle must be equal to 135 degrees. In order to formulate the sum of the angles on the upper side of AB at point E to 180 degrees, this angle must be equal to 135 degrees. Okay, then we focused on the green triangle ADE, and we have the rule that the sum of the angles in any triangle is equal to 180 degrees. So which angles we have here? We have x over 2, y over 2, and 135 degrees. In total, the sum of those 3 angles must be equal to 180 degrees. And again, the sum of the 3 angles in the green triangle AD must be equal to 180 degrees. So we subtracted 135 degrees from this equation. We found out that 180 degrees plus 135 degrees is 45 degrees. And in this side of the equation, we left with x over 2 plus y over 2. We multiply this equation by 2. 45 times 2 is 90. X over 2 is, times 2 is x. Y over 2 times 2 is y. In conclusion, we found out that x plus y equals to 90 degrees. We subtracted x from this equation and found out finally that y equals to 90 degrees minus x. Okay, in the next step, we implemented the Pythagoras theorem on the pink triangle, triangle DOB. According to the Pythagoras theorem on the pink triangle, triangle DOB, cosine x equals to r squared plus r squared minus 2 squared, that is 4. So it is r squared plus 4 over 2 times r times r. Repeat again. In the pink triangle, triangle AODB, cosine x equals to r squared plus r squared minus 4 over 2 times r times r. So cosine x equals to r squared plus r squared is 2r squared minus 4 over 2 times r is 2r squared. So cosine x equals to, we splitted this expression into two parts. The first part is 2r squared over 2r squared, and the second part is minus 4 over 2r squared. Okay, so then we have 2r squared over 2r squared is 1, and minus 4 over 2 is minus 2. So in the numerator we have minus 2, and the denominator we have r squared. Okay. So cosine x, according to equation number 1, cosine x equals to 1 minus 2 over r squared. Then we focused on the yellow triangle, triangle AOB, and we implemented here the law of cosines. According to the law of cosines in the yellow triangle, triangle AOB, cosine y equals to r squared plus r squared minus square root of 2 squared. Square root of 2 squared is 2, so it's 2. So it is r squared plus r squared minus 2. Over 2 times r times r. Repeat again, in the yellow triangle AOB, according to the law of cosines, it is actually cosine y equals to r squared plus r squared minus 2 over 2 times r times r. So cosine y equals to r squared plus r squared is 2r squared minus 2 over 2 times r is 2r squared. So cosine y equals to, we splitted this expression into two parts. The first part is 2r squared over 2r squared, and the second part is minus 2 over 2r squared. Okay, so 2r squared over 2r squared is 1, and minus 2 over minus 2 is minus 1. So the numerator we have minus 1, and in the denominator we left with r squared. So according to equation number 2, cosine y equals to 1 minus 1 over r squared. In the next step, we defined 1 over r squared as t, and then we substituted 1 over r squared, those two equations, equation number 1 and equation number 2, by t. And we found out here that according to equation number 1, cosine x equals to 1 minus 2, and 1 over r squared is t, so in total it is 2 minus 2t. Okay, here cosine x equals to 1 minus 2t, and here we have cosine y equals to 1 minus 1 over r squared, and 1 over r squared is t, so in total we have cosine y equals to 1 minus t. According to equation cosine y, but before that, so I found out actually that cosine y equals to 1 minus t, but before that, in equation number 2 we have cosine y, and we already found out that y equals to 90 degrees minus x. So we can substitute y in this equation, equation number 2, by 90 degrees minus x. So here cosine y equals to, cosine y is 90 degrees minus x, so it is cosine 90 degrees minus x. And we have the trigonometric identity that cosine 90 degrees minus x equals to sinus x. In conclusion, we found out that cosine y equals to sinus x. So we substituted cosine y in equation number 2 by sinus x. And found out and we got that sinus x equals to 1 minus 1 over r squared. So sinus x equals to 1 minus 1 over r squared is t. So in total, sinus x equals to 1 minus t according to equation number 2. And according to equation number 1, we already found out that cosine x equals to 1 minus 2t. So we have two expressions. We have the expression for cosine x and the expression for sinus x. In the next step, we use the trigonometric identity that sinus square x plus cosine square x equals to 1. So sinus x equals to 1 minus t, therefore sinus square x equals to 1 minus t squared plus cosine square x. Cosine x equals to 1 minus t, therefore cosine square x equals to 1 minus 2t squared. It must be equal to 1 according to this the trigonometric identity. So here we open the brackets of this equation. 1 minus t squared equals to 1 squared, that is 1, plus t squared minus 2t. And we open the brackets of this equation. So 1 minus 2t squared equals to 1 squared plus 2t squared, that is 4t squared, minus 2 times 2t is minus 4t, and it is equal to 1. So here we have t squared plus 4t squared is 5t squared, minus t minus 4t is minus 6t, and we have here 1 in both sides of the equation, so 1 will get cancelled, and we left only with this one. So in conclusion, we found out that 5t squared minus 6t plus 1 equals to 0. Then we substitute minus 6t by minus 5t minus 1t. And we got that five t squared minus 6t is minus 5t minus t plus 1 equals to 0. Then we took out 5t as a common factor from those two expressions. So inside the brackets we left only with t minus 1. Then we took out minus 1 as a common factor from those two expressions. So inside the brackets we left with t minus 1 equals to 0. Then we took out a common factor of t minus 1 from this expression. So from these two expressions, so inside the brackets we left with 5t minus 1 and all equals to 0. So here we have two solutions that are possible for t. Either t minus 1 equals to 0, or the second solution 5t minus 1 equals to 0. So according to the first solution, t minus 1 equals to 0, that is to say t equals to 1, and according to our definition t equals to 1 over r squared, so we substitute t by 1 over r squared in this equation, and found out that t is 1 over r squared equals to 1. Then we multiplied this equation by r squared, and we found out that r squared equals to 1. Then we took a root out of this equation and found out that r equals to the plus minus of square root of 1. The negative square root of 1 is minus 1. But minus 1 is not possible because the radius is a length, and length must be a positive number. So we cancel this solution and we left only with the positive square root of 1, that is 1. So r equals to 1, and according to the second solution, 5t minus 1 equals to 0. We added 1 to this equation, and we got that 5t equals to 1. We divided this equation by 5, and we found out that t equals to 1/5. And according to our definition, t equals to 1 over r squared. So we substituted t by 1 over r squared, and we found out that 1 over r squared equals to 1/5. We cross multiplied this equation, and we found out that r squared equals to 5. Then we took a root from this equation and found out that r equals to plus minus the square root of 5. But the negative square root of 5 is not correct answer because r is a length and f must be a positive number. Therefore, we cancel the solution and we left with the only solution that r equals to the positive square root of 5. That is the first solution, and the second solution is that r equals to 1. Then we focused on our drawing. We have a record dB equals to 2 units. It is very easy to see from the drawing that chord dB doesn't pass through the center of the circle, that is to say, chord dB doesn't pass for point O, that is the center of the circle. Therefore, chord dB cannot be the diameter of this circle, okay, because it doesn't pass through the center of the circle. And we also know that the diameter of any circle is the longest chord in the circle. So the diameter to r must be greater than dB, because dB is not the diameter of the circle. Okay, so here the diameter to r must be greater than dB. Why? Because dB is not the diameter, and the diameter is the longest chord in the circle. Therefore, the diameter to r is greater than dB. It is given us the equation that dB equals to 2 units. So we substitute dB by 2 in this inequality, and we found out that 2r is greater than dB, that is 2. We divided this inequality by 2 and found out that r is greater than 1. So, because of the fact that r is greater than 1, r cannot be equal to 1. So we cancel the solution that r equals to 1, and we left with the only solution that is possible, that is r equals to the square root of 5 units, or in terms of numbers, r equals to 2.236 units. I repeat again, the radius of this circle equals to either square root of 5 units, or in terms of numbers, it is equal to 2.236 units. Okay, thank you very much.